Okay, so we're now looking at question number 3 from the January 2024 International A-Level Decision 1 Mathematics paper. And here we are given a network diagram and they want us to use Dijkstra's algorithm to find the shortest path from A. Was it not right? So we want to find the shortest path from A to J, and we want to state the length of the shortest path from A to J as well. So if we go to the table right over here, we are going to start at A, so we're going to label A as our starting vertex, and A has a total value of 0, and then from A we can go to either B, C, and D, so we want to consider each and every single one of them. So from A to B it has a total length of 17, and from A to C it's going to have a total length of 28, and from A to D it's going to have a total length of 39. So out of the three options that we have here, B, C, and D, we want to pick the one with the smallest walk-in value, and we want to lock that value inside the final value. So if we go over here, we have the 17, which is the smallest because 17 is smaller than 28, and 17 is also smaller than 39. So we want to lock in 17 inside the table as our second value, and then we write next to it 17. Now we're going to repeat the same process again for every single node. So from B, we got 4 vertices that we can connect to B that have not been done so far. So we got this one that connects to D, and then we have this one that connects to C, and this one that connects to F, and this one that connects to E. So let's just consider every single one of them. So 17 plus 28 is going to be 45. And then we got 17 plus 38 is going to be 55. And then we got 17 plus 8 is going to be 25. And since 25 is smaller than 28, we can cross out 28. And then we got 17 and 20, which is smaller than 39. So this will be 27. 17 and 20 is going to be 37, which is still smaller than 39. So we're going to cross out 39. So now we want to pick the smallest value from the table, which is going to be for now we want to consider the numbers that are not locked in. So we already have B and A locked in. So we want to consider the ones that we have not chosen yet. So that's going to be the vertex C, F, E, and D. And we want to pick the one with the smallest value, and that's going to be the vertex C. So we want to lock in C as the third vertex, and it has a total value of 25. Now we want to connect everything that connects back to C that has not been connected. So since we've already done B, we cannot go over B again. So we can do this one over here. 25 and 10 is going to be 35, which is smaller than the 37. So we can cross out 37. And we got 25 and 25, which is 50, which is smaller than the 55. So we can cross that out. And yeah, I think that's it. So we want to pick one of these values over here, and the smallest one is going to be the 35 down here, which is at D. This one is going to be number 4, and it's going to have a final length of 35. Now we want to do the same thing again. This is connected here to F, and this one connects to J, and this one connects to G as well. So we want to pick the smallest value, which is going to be 35 plus 12, which is going to be 47. 47 is smaller than 50, so we can cross out the 50. Now we got 35 plus 55, which is going to be 90 for J, and then we got 35 and 37, which is going to be 72 for G. So once again, we want to zoom out, and we want to take a look at which vertex has the smallest value. So in here we have E at 45, J at 90, F at 47, and G at 72. We can see that E over here has the smallest value, and it has 45 inside of it. So we want to lock in E as the 5th value with a total length of 45. Now, since we've already picked E, we want to connect everything that connects to E. So we have H over here, which is going to be 45 and 47, which is going to be 92. And then that's the only thing that connects to E. So we want to take another look again, and we want to pick the smallest value. So in here we have 92, here we have 90, here we have 47, and here we have 72. So we want to pick the smallest one, which is F over here, and it has a final value of 47. So we want to lock that in. So we're going to go here. This one was which one? This one is going to be number 6, and it has a final value of 47. Now we want to connect everything that has not been connected so far to F. So that's going to be activities, or I mean edges that connect FJ and to G as well. So 47 plus 40 is going to be 87. 87 is smaller than 90, so we can cross out 90. And then we got 47 plus 20, which is going to be 67. Now 67 is smaller than 72, so we can lock that up. We can cross that out. G. So we want to pick the smallest value, which we have here. So we got 92, 87, and 67 over here. And we know that the 67 is the smallest, so we want to lock them as number 7. And the total value was 67. So now we want to connect everything that connects to G, which is this 11 over here, and this 18 to J and H. So 67 plus 11 is going to be 78, which is smaller than this 92, so we can cross that out. And we also have the 67 and the 18 over here. So 67 and 18 is going to be 85, which is also smaller than this 87, so we can cross that out. Now from these two, we want to pick the one with the smallest value, which is going to be this 78 over here. So this one is going to be, which one is it? Yep, this one is going to be number 8. And it's going to have a 78. We want to lock that in. Now there's only one vertex that has not been connected so far to H that we want to connect to, which is J. So it's going to be 85 plus, 78 plus 5. So that's going to be 83, which is smaller than the 85. So we are going to lock in the 83 as our final value, number 9. And it has a value of 83. And so once we have filled our tables, we want to find the shortest path from A to J. So we want to start at the end vertex, and we want to go all the way back to the starting vertex. So you can maybe pick out a highlighter, or you can just trace it down here in the blank place. Just do whatever you want to do. So from J, the way you do it is you want to find which value gave you this 83. So we know that this 83 came from this 5 out of the 75, right? So we know that, okay, wait, let me explain that again. So we want to find, where did this 83 come from? Well, we know this 83 came from the 78 plus 5. So we want to go from here, from J to H. And now we want to ask, where did this 78 come from? Well, the 78 came from the 67 down over here. So this is going to be the second path that we're going to take. Now we want to ask ourselves, where did we get this 67 from? Well, this 67 came from F. So that's going to be 67 minus 20, which is going to give us this 47 over here. Now we want to ask ourselves, where did we get this 47 from? Well, this 47 came from 47 minus 25 is not 25, so it's not C. It came from D, which is the 47 minus 12 is going to give us 35. So now we want to do the same thing again. Where did this 35 came from? Well, this 35 came from the C over here. So we want to highlight that. And now we want to find, where did the C value come from? Well, it came from B. And we know that B came from A. So now we have the shortest path over here. And we can write it down, which is A, B, then it was C, D, and then it was F, G, and then it was H, F. No, J. H and J. And then the shortest path is going to be the value that is inside this box over here, which is going to be the 83. And this is it for part A, I, and double I for question number 3. And now we can go to question number. We can go to part B from question number 3. Okay. So now for part B, it says the roads between the towns must be inspected. Claude must travel along each road at least once. Claude will start the inspection at A, and is going to finish at J. So let's just underline these. Claude wishes to minimize the length of the root inspection by considering the pairings of all relevant nodes. Let's just underline this as well. Relevant nodes. Find the length of Claude's root state, the arcs that will be needed to traverse twice. So if we go over here, I've already circled the odd vertices, and the dotted ones are the starting and ending vertices. So we're going to start at A. A is also odd. Let me just write the number of degrees. So A has 3. This one has 1, 2, 3, 4, 5. This one has 1, 2, 3, 4, 5. This one has 1, 2, 3, 4. This one is 4, which is even. And then we've got 1, 2, 3. So this one is odd as well. So now for the consideration, we are going to take the, oops, wasn't all writing. Yep. So we want to consider the relevant nodes. And most people are going to think the relevant nodes here are going to be A, B, F, and H, which is completely wrong. We do not want to consider A since A is not relevant. The only reason we're not taking A is because we are starting at A and it's already odd, so we want to leave that alone. But since we are ending at J, which is originally even, we want to force it to behave like an odd vertex for the matching step. So since we are forcing J to behave like a odd vertex over here, we want to consider it as an odd vertex. So that's going to be B, H, and F. And then we got J. We're going to consider it, which is even. It's even. Let me just write it here. Even, but chosen as finish. So now we can continue and we can consider all of these combinations together. So we are, let me just go somewhere with a little bit more space. Okay, this is part B, right? Yeah. Okay. So we are going to consider BH, BF, and BJ. So we're going to add this with FJ for this one, and then this one we're going to add HJ. And for this one we're going to add FH. So we want to find the shortest path between these combinations. So we want to find what BH is first. So let's just go up here. I'm going to start from B and we want to go to H. So the shortest path is going to be, well, we can consider this 28. Wasn't all right. Yep. So we can take this 28 and 47, but that's obviously way too big. So we're not going to consider that. So we can look at this 8 over here. Let me highlight it, which is the shortest thing. So we could go from B to C, and then we can go to F, and then from F we can maybe go down here and then go here, if that works. And yeah, that's definitely the shortest. So the shortest path from B to F now is going to be this 8, and this 10, and this 12. And now from this F we can go to G and we can go to H. So let's just write this down. So that's going to be what's that going to be? BH. So that's going to be 8 plus 10 plus 12 plus 20. Yeah, plus 20 plus 11. Plus 20 plus 11. Let me put that in brackets. We want to find FJ. So we want to go back up there. And since J is the finishing one, we can just take the total value for J, which is 83, and we can subtract the shortest path for F, which is going to be 47. So that's going to be 83 minus 47, which is going to give us the shortest path. So plus 83 plus 83 minus 47 is going to be 36, which is going to give us, let me check, calculator. 10 plus 12. So we are going to get 97 for this one. Let me just take this down somewhere with more space. Okay, so now we can continue over here. So this one was 97. Now we're going to find BF and AJ. So BF is going to be all of this up until 12. So that's going to be 30 plus AJ. Since we already are J, that's going to be 5 over here. So we're going to consider that. 30 plus 5, which is going to give us 36. Or 36 is most likely going to be the smallest one. Then we've got BJ. So we're going to go here. And we are going to repeat the same thing. 83 minus 17, which is going to be 66. Plus an FH, which was 20 plus 11. So that's going to be 20 plus 11. 66 plus 31, which is 97. So the shortest pair in here is going to be BF and AJ. So we want to consider this one. So we want to repeat them since they are the shortest path, and we want to minimize the total cost. Minimize the total distance that we are going to traverse, since we are moving along every town. We want to visit every town, so we want to keep the distance as short as possible. So while repeating the distances, it's going to make more sense to repeat the ones with the shorter length than the longer ones. So now we're going to get a total new length, which is going to be the weight of the network plus the shortest pair that we found. So the weight over here was written somewhere. Yeah, 458. So total length equal 458 plus this 36 over here, which is equal to 458 plus 36, 494. And it also says state the arcs that will be needed to be traversed twice. So that's going to be BF and FH. But I think in the mark schemes it needs to be more accurate than this. So we want to state the arcs that takes me from B to F as well. So it's going to be, let's go back here, BC, then CD, then DF. So let's just write that down. BC, then CD, and then DF. And then we want to repeat, which one is it? FH, which is FG and GH. So let's just write these down. FG and GH will be traversed twice. Now we can look at part C from this question. And it says here, okay, yeah. So it says if Claude does not start at A and finish at J, a shorter inspection is now possible. So since they removed the restrictions at A and J, we want to consider the new path. So it says determine the 2 towns which Claude should start and finish so that the route has minimum length. Give a reason for your answer and state the length of this route. So you know how earlier I told you should consider the relevant nodes for this question, for this type of questions, and not the odd vertices alone. This is where you want to consider the odd vertices alone, since you no longer have the restrictions, so you can start and end anywhere. So you want to start and end at the shortest odd vertices. So let's just consider the odd vertices again. So consider odd nodes, and that's going to be this A and this B and this H and this F. We're no longer going to consider J because it's an even node, and we no longer need it to behave as an odd node anymore since it's no longer our finishing point. So let's consider A, B, F, and H. So we want to find the shortest combinations for each and every single one of them. So we're going to have AB, we're going to have AF, then we're going to have AH, This one is going to be plus FH. And this one is going to be plus BH. And this one is going to be plus BF. So we can use Dijkstra's to find the shortest path from AB, AF, and AH. So let's just go there. So we are interested in this 17. We are interested in this 47. We are interested in this 78. So let's just go write these down. This one will be 17 plus, this one will be, I forgot, this one was 78 plus, this one was 47 plus. So now we want to find the shortest path from FH, BH, and BF. So I think we already have these up here. Do we? Yeah. So BF was 30. FH was 97. Oops. This one was 97. BF was... Which one was BF? Did BF, no? BH... Oh, BH is not... Okay, I'm sorry. BH is not 30. BF is 30. BH was 8 plus 20, 30 plus 20 plus 11. So it's going to be 61. So now we want to consider all of them again. So AB is 17. Let me just highlight it so it doesn't get confusing for later. So I can just color code them. AB 17. FH is 97. And then we had AF, which was 47. And then BH, which was 61. And then we had AH, which was 78. BF, let me pick a different color. BF, which is 30. So we need to remember these for later. So we're going to find the total length here. We actually don't need to find the total length. We just want to pick the shortest one right away. So just forget about the addition and all of that. So we could see that AB over here is going to be the shortest. So we want to repeat the arcs A and B. So repeat A and B. Now, since we are starting at, we're repeating A and B, we can no longer consider A. Let me just take red. We can no longer consider A and anything with an A and anything with a B. So we need to start at, we have, oops, I think I filtered out something that I was not supposed to. No, okay, yeah. So we need to start at F and end at H, or we can start at we can start at H and end at F. So these are our relevant, our starting and ending vertices for the, or for this, what's it called again? Yeah, for this inspection. So we want to repeat AB since it has the shortest arc. We want to start and finish at either F or H. So does it ask us to find the length as well? Give a reason. Cloud should start and finish, so that determine the two terms, give a reason, and state the length. So we want to find the length. So that's going to be 458 plus 17, which is going to be 458 plus 17. It's going to be 475 kilometers, which is definitely shorter than our previous, was it? 494 kilometers. And this is it for... Okay, so I've noticed that I've forgotten to do the last part of this question, which says give a reason. I did not give a reason, so let's just quickly write the reason over here. So since we want to repeat AB, because let me just go here. So the AB here is the shortest node. Therefore, we must consider it, or repeat it, actually not consider, repeat A and B. And then, therefore, the inspection must start at either F or H. This should be shortest. Okay, I think this is it. So this is it for question number 3, part C. In addition, this is also the end to question number 3. And now we can go on to the next question, which is question number 4.